Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. And in this video, we're going to be working with some equations that have a variable on both sides of the equal sign. And so if you noticed, I give this first one, and this is actually from one of the previous notes where I gave this to you as a U-return problem, but I want to make sure they can kind of see what this looks like. So again, just like we've been doing, you want to be able to draw this picture first. So again, use that key for yourself to be able to draw it out, or you can use those algebra tiles, whatever works best for you. But you want to make sure that you can see the picture, the pictorial representation, the model, whatever you want to call it, as long as you're visualizing what it should look like. So on the left side of our equal sign is this space here, and on the right side we have our 3x plus 6. So let's go ahead and kind of represent what we have. So we have 4 positive x's. So I'm going to take 1, 2, 3, and 4. And then I have 8 negative 1s. So I'm going to have 8 and then negative 1. So I want to have these shaded in. So 1, 2, and 3, and 4. I'm actually going to take a shortcut. Copy, paste, boom, 8 right there. All right. On the right side, I have 3 positive x's, and I have 6 positive 1s. So again, notice that you're seeing I have a difference between these. I need to make sure that these are different ideas. Again, this is 1 positive x, and this is 1 positive 1. So now, how do we balance this equation? Well, you always want to look for this. You want to always look for the lowest coefficient. And so that's that number or that value that is attached to your variable. So your coefficient on the left side is a 4, and on the right side it's a 3. So you want to see, okay, which out of those two is the lowest? Well, we know that 3 is lower than 4, so this is going to be our lowest coefficient. So let me actually let me highlight that real quick. I'm going to say that this is going to be my lowest coefficient. So that's what I have to add the opposite to both sides. That way I have a nice clean answer. So this is what I'm going to do. I'm going to start with this. I'm going to have to add the opposite. So what's the opposite of 3x? It's going to be 3 negative. So again, I'm going to add 3 negative x's to both sides. 1, 2, and 3. Again, the reason why we do this is this makes 0 pairs. Again, 1 positive, 1 negative cancels out. 1 positive, 1 negative cancels out. And 1 positive, 1 negative cancels out. Same thing on the left. We can clear out our 0 pairs. Okay, so what can we do now? Well, again, just like in the warm-up, you want to make sure that you can get all the variables to one side, which we did. We have the variable on the left here. Now we want to get all the constants on the other side, so that way we get a variable equals a value. So how do we get rid of this 8 negatives? Well, we add the opposite. So what's the opposite of 8 negatives? That's right, 8 positive. So I have 1, 2, 3, 4, and then shortcut, copy and paste, because I want to make sure that we have, again, our 0 pairs. Whatever you do to one side, you want to make sure you do to the other. So I have 4 and then 8 to that side as well. What happens next? Well, we can see that our 0 pairs cancel out. 1 negative, 1 positive, 1 negative, 1 positive, 1 negative, 1 positive. And so what are you end up with? Well, I have 1 positive x, which is what we're looking for. I have 2, 4, 6, and then 8, 10, 12, and 14. So we would say that x equals 14 for this one. And how do we check that? Well, again, you can use your back substitution, or if you want to make it even simpler for yourself, you can do this. So let me actually slide this up a little bit. I'm going to bust out the Desmos calculator for ourselves, and we could say this. You have to make sure that since we now have expressions on both sides of the equation, meaning we have variables on both sides of the equation, you want to make sure that you can write only one expression in one line. So again, that's why I don't put, equals 3x on 3x plus 6. I don't write that all on one line. I have to make sure that I have it separated. So again, I have, let's actually, can I box this in like this? Maybe it'll make it a little bit easier to see. So I have this. All right, so I have this right here. So I have 4x minus 8, and then I have, let's do in green, I have my 3x plus 6 right here. And we're trying to make sure that those two items, or those two expressions, are equal, meaning they give out the same amount, which we know is correct because both of those lines are equal. We're saying an equation is two equivalent expressions. The reason why we knew we got a correct answer is because we typed in and we said, hey, does x equal 14? And since these two lines are the same value, we know we are correct. All right, let's try another one. All right, so it says 5x. So let me draw that out. I have 1, 2, 3, 4, 5, and I have 9 negatives. So let me do 1, 2, 3. Again, make sure you're taking your time and drawing them carefully. I know in other videos they can get a little bit sloppy, but as long as you can determine, hey, these are x's and these are 1's, then the rest of it will be a lot simpler. On the right side of our equation, we have 4 x's, 2, 3, and 4. And then we have 11 positive 1s. So we get 1, 2, 3. And let me do copy and paste. Thank you, technology. You are a savior and also deterrent, but that's okay. All right, so we got 11 positives on the right. So now, what do we got? Well, we're going to look for that lowest coefficient. So again, look for those two variable terms. So we have our 5x and our 4x. And we can say, okay, which of those two is lower? Well, very simply, we know that our 4x is lower. And then we say, okay, we want to add the opposite to both sides of that amount. So we're going to say, add 4 negative x's to both sides. So 1, 2, 3, 4, and whatever I do to one side, I gotta do to the other. 2, 3, and 4. Again, our 0 pairs, those cancel everything out, and they also cancel things out on the left side. And so what are we left with? We have 1x on the left. And just like the previous one, we will make sure we can add the opposite to both sides. So we have, let me actually clear that out. So I have 1, 2. I'm adding 9 positives now because I see that my 1x, it's all by itself on the left, and so I want to get rid of this negative 9 here. So I'm going to have to add 9 positives to both sides. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I do copy. Again, same thing to the other side. Be careful though. And I put 1 over there. So let me make sure I have 9 that I'm adding to both sides. Make sure I have 9 added to both sides. All right. So now, again, our 0 pairs, these all cancel out. And so what are we left with? Well, we have 2, we had 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so we're saying that x equals 20. So we're going to see if that is actually correct. Again, using that Desmos calculator, or you can use that back substitution. You type it in for yourself, and we're saying this. We're saying, all right, our first 2 lines, again, you type in carefully, and so we say, all right, 5x minus 9, and we have 4x plus 1. Since, let me try highlighting this time. Since we said, all right, 4x plus 1 is right here, and then we say 5x minus 9 is over here, and then since we're saying that those should be equal, we're looking for these two values to be equal, which they are, and so we know we are good. Again, show your work on the side if you'd like, so that way you can get used to switching between the model and the picture. Alright, so one last time with the picture, and this should actually say, I believe it was I believe it's 7 minus 8x, yeah, that's what it should be. So let me save that real quick. Alright. So it has 7 minus 8x equals x minus 11. So now, always find where's that lowest coefficient at. So we can see, hey, even though you see that 8 there, you have to see, okay, hey, that's a negative 8. So you have to make sure that you're saying that's a negative 8. So since that's our lower coefficient, we know that that's what we're going to add the opposite to both sides. So let's actually draw this out first. Let me not get ahead of myself. So I have 7 positives. 1, 2, 3. I can copy, paste. So I have 7 positives. I have 8 negatives. So I got 1, 2, 3. And make some nice room here. Again, you can take this time to pause, rewind, slow-mo, instant replay, all that good stuff, so that way you can have a perfectly drawn picture just like mine. Alright, so I have 8 negatives on the left, and then I have 7 positives on the left. So I'm going to make sure that I have 7 positive 1s and 8 negative x's. On the right side, I have 1 positive x, and I have 11 negative 1s. So let's make sure we have that right amount. And one more. Alright, so let's see, I got 2, 4, 6, 8, 9, 10, and 11. Alright. We said that we have to add 8 positives to both sides. So let's do that. So you got 1, 2, 3, 4, 5, 6, 7, and 8. The reason why I'm kind of covering it up is because I'm going to be able to cancel those out. So that way it's a little bit easier to show. So I have 6, 7, 8. It doesn't really matter as long as you're seeing that, hey, I have everything on one side versus the everything else on the other side. Again, my 0 pairs cancel out. My 0 pairs cancel out. And so what am I left with? Well, I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9 positive x's. So 9 positive x's. I can kind of maneuver these a little bit so I have enough space. And what else do I have? I have 2, 4, 6. I still have those 11 negatives. So since I have my x's on this side, I want to make sure I can get it to the other side, because we're trying to find out what does one of these rectangles equal. So I'm going to have to add 11 positives now to both sides. So I go 1, 2. Let's actually make this a little bit easier for ourselves. Alright, so we got all these in here. Again, I can kind of start showing my 0 pairs on one side. And I need one more. Alright, do the same thing over here. So I got 1, 2, 3. I have 6, 9, 12, but I need to take that one out. So again, I'm just adding 11 to both sides. So I have 3, 6, 9, 12, 3, 6, 9, and then 11. Okay. Again, our 0 pairs cancel out. And so we have, currently, we have 9x on the right, and we should have 18 positives on the left. And as you notice, I kind of start organizing them. I can kind of group them together in rows or columns. So let's see, I have 4, I have 16, okay, 18. So now I want to actually give a shout out to a student of mine, he kind of showed me this. I'm going to give a shout out to Juan. He said that, hey, I know that as I'm trying to now see, okay, I have 9x equals 18. So each of these 1x's, how many 1 positives does it contain? And what he did was this. He kind of spread them out, and he said, okay, I'm going to take 18 of these ones. I'm going to go one at a time. So I'm going to put them into those groups. Let me actually make sure I can group these here. So let's bring to the front. There we go. And he did one by one. He kind of put them inside of those variables. And this is another way if you want to do it, so that way you can see, because you're trying to equally share that total amount. And so if you notice, if I split these into equal groups, how many groups do I have? Well, for every 1x, I have 2 positive 1s. So what does that mean? Well, again, I can show it like this. Let me actually go back. I can say, all right, for every 1 or Juan x, I can say that, hey, there is two positives in here. Again, I can kind of circle it. I can put them inside of one another. As long as you're able to show that x equals 2, you know you're good. All right, so let me kind of move this aside a little bit. We can check our answer. So let's see. All right. Again, you want to make sure you can type in your original expression. So we said that the 7 minus 8x, we do that first. And so I'm going to have that on my left side here. So we're trying to make sure that these two expressions are equal. Again, that's what an equation is. Two equivalent expressions. So we have 7 minus 8x equals x minus 11. And then we said that x equals 2. And since, again, these two values are equal, we know we are correct. Again, the picture really helps show that, but we want to make sure that we can see it without the picture as well. So let's now transition to that. All right, so try out that last one with the picture to yourself. Again, try drawing it out and showing it there. All right, so now let's see if we can do this without the picture. So now, very simply, I'm going to say, all right, again, always follow that DCM, meaning that distribute property, combine like terms, and manipulate the variable, or we can say the multiplicative inverse. Since there's no distributed property, we know we can cross that one off. Combine like terms, well, I need to get these x's all on one side. And I say that, hey, I know that the -4, that's the lower coefficient. So that -4, that's going to be my lower coefficient. So I'm going to add 4x to both sides. The 4x on the right cancel out. And so the positive 4 comes down. And what are we left with on the right? Well, very simply, just a 1x equals 4. Double check your answer as always. And you can see, hey, on the left, I write one expression. On the right, I write this, another expression. And since these two are the same value, you know you are correct. Similar idea. We have, again, our DCM. Is there any distributed property? Nope. And so we can cross that one out. We want to combine like terms, so we want to get all those variables on one side. We see that our -5x, that's the lower amount. So we want to add that to both sides. So add 5x to both sides. Again, make sure you're adding it to the right column, meaning you're combining like terms. The 5x's on the left cancel out. And so what are we left with? We're left with 10 equals, and then 2 plus 2x. still using our inverse operations and still combining like terms. I want to get this 2 over to the other side since we want to get all the constants to one side. Again, we can subtract 2 from both sides now. The 2's cancel out since they are additive inverse, meaning they are opposite from each other. The 2x comes down, and so we have 2x equals 8. Always divide by the coefficient. That means our multiplicative inverse property. And so we divide by 2 to both sides, and we end up with x equals 4. Usually I like to circle my answer so that way I know what to check with. And so when I do check, again, you can type it in for yourself using that calculator. Let me put it on this side. Maybe not. Let's put it on this side. All right. So it says, again, our 10 minus 5x, and then our 2 minus 3x. And we said x equals 4. Again, these are each separate lines in that calculator, but since these two lines are equal, that means that we have a true statement. And last two, I believe. Yep, last two on here. A little bit tougher now, but equally as opportunistic. So again, bust out that DCM. Anytime you see an equal sign, write those 3 letters down. So we're going to do distributed property first. And so we say, all right, let's do -4 times a -20x is a positive 80x. And we do -4 times positive 15 is a -60. Again, since they have the same sign in the first one, the product has a positive, and since they have different signs, the product is going to have a negative. So again, we can write that expression right below where we had. All right, so there's no other distributive property to do, so we can cross that one out. Let's now combine our like terms. So let's combine, again, our variable terms. Let's make sure we can work on one side first. So we have a positive 18x and a positive 6x. We can combine those two together, and we end up with 12x. Everything else stays the same. Now we can still get our variable terms on one side, so I'm going to want to get rid of this 12x and then move to the left side. So we're going to add the opposite, meaning we subtract 12x from both sides. These cancel out. And we're left with what? Well, we are left with 8 on the right, and we have 68x minus 60 equals 8. Again, one last step, or excuse me, last 2 steps. Add 60 to both sides. Trying to get all the constants now on the other side. And so we have 68x equals 68. Again, always divide by that coefficient. And you should end up with x equals 1. Always check your answer. You can use that Desmos calculator, or you can use that back substitution like we've been doing. And we say, okay, since these two amounts are equal, we know we are correct. Make sure those are separate lines for each of those. And then last one here, it has -2 times quantity x plus 20 as plus 19 equals -19 minus x minus 20. So there's a lot going on. Make sure if there's any like terms on the same side, meaning on one side of the equation, you want to work with those first. But you want to make sure you can do that distributive property before that. So let's do just that. So we do -2 times our positive 1x is going to be -2x. And we do -2 times a positive 20 is a -40. So we can write that right below where we had it. Again, we can work on one side of the equation. So I'm going to highlight those constant terms. So I'm going to say, all right, our -40 and our positive 19, those are the same, along with a -19 and a -20. Again, I'm going to work on one side at a time. So again, -40 plus 19 is -21, and then negative 19 minus 20 is negative 39. So let me actually draw 2 lines here to just make sure that we can grasp that. Alright, so these two go down to here, and these two go down to that. Okay. So now, want to look for that lowest coefficient. Since we have variables on both sides, you want to make sure you can add the opposite of the lowest coefficient. So which one's lower? We have a negative 1x and we have a negative 2x. So we know that that is going to be our lower coefficient. And so that's the one that we're going to add the opposite of. So we're going to add positive 2x to both sides. On the left, they cancel out. On the right, we're left with, negative 39 plus x equals negative 21. Be able to get the since all of our variables are on one side, we can now get the constants on the other. On the right side, those cancel out. And we're left with our simplified answer. We have x equals 18. Okay, double check it as always. Actually move that over, it's kind of aggressive. There we go, that's a little bit more reasonable. Alright, check it on Desmos. Again, make sure those two expressions are typed in exactly how they look. Define what that variable is, and then we see, okay, since these two lines are equal, we know that we have a true statement. Make sure that you can take some time, stretch out your hands, make sure you can use those remaining 2 spaces to work on that W11. I would suggest maybe if you're having a little difficulty, maybe try drawing the model for the first one and then actually solving it for the other. I'm going to actually go back and do this one too. So if you wanted to check your work, you certainly can. Very simply, I can show the model, so that's what I'm going to do first. So let's do negative 10. One more. Alright, so I have 10 negatives, and I have 8 positives. And then I have 1 negative x. On the right side, I have 5 positives. Again, this takes a little bit more time, which is why I originally skipped it, but I can go back to it now. And then I have 10 positive ones. Alright. Again, you want to work on one side of the equation first. So again, I can maybe make some 0 pairs. So let's see, I can pair up. If I have 8 positives and 8 negatives, if it would let me select it, there we go. 8 positive and 8 negatives, those cancel out. Which has a lower coefficient now. We can say that, hey, I know that negative 1x, that's going to be my lower coefficient. So I'm going to say that, hey, that's my lower negative coefficient. And so I can add the opposite to both sides. So I'm going to add a positive 1x to both sides. On the left side, our 0 pairs cancel out. On the right, we are left with how much? We're left with 6 positive x's and these 10 positive ones, which is what we want to get rid of right now. So if we have 10 positive ones, we need to now add the opposite, so that's going to be 10 negative ones. Let me actually use this. So I'm going to have 10 negative ones to both sides. Let me do on the right now. Alright, so I have 10 positive ones and 10 negative ones. Those cancel out. And so what are we left with? Well, just like we did in that previous one, I can, a little bit better, I can group these now. So let me actually group them how I was saying. All right, I have them kind of spaced out just a little bit. So as you have all of these on one side, I can kind of line them up and say, all right, how much is each of these x's going to be worth? Meaning, how much can each of those x's contain? Well, if you see very carefully, each of those x's is going to contain a -1. Excuse me, 2 -1s. So I can kind of group them off like so. Again, you can show it using circles, whatever works for you. To check our answer, let me actually bring this to the front one more time. To check our answer, again, you can type in your first expression, your second expression, and then what you think your answer is. Since those two are equal to each other, we know we are good. Thank you for all of your patience. As it's a little bit longer, be sure to slam that subscribe button. Maybe do a 100 subscriber giveaway. Yeah, let's do a Starburst bag to the 100th, or we'll do a what's it called, a raffle. Let's do a raffle for the 100th subscriber. Take care.